While loop patterns. We have previously seen a number of loop patterns related to for loops. This time, we will see general patterns that are useful for while loops. The while loop patterns vary much more widely than the for loops, since the power of a while loop is more unbounded. We have already talked about how for loops are better for iterating over a range of numbers. However, one immediate advantage for while loops is when we need to iterate through numbers non-sequentially. In the code shown below, instead of decreasing by 1 each time, we are instead having the value in counter. This demonstrates exponential decay and will decrease much more rapidly down to a number less than 1. Any kind of numeric conditions can be used with while loops, making them more flexible than for loops, at least with numbers. Just as we saw that a while loop can replace a for loop for processing numbers, we can also use the while loop to process a list. This allows us to process the list in interesting ways that previously were not possible with simply a for loop, which just iterates through the sequence from start to finish. Now we can jump to different places in the list. As before, however, you must be careful to avoid accidentally looping forever or indexing out of bounds. Remembering to update the current index is very important. Before you run this program, try to predict what will be printed. Another use case where a while loop is more useful than a for loop is dealing with repeated user input. For instance, the read, evaluate, print loop, or REPL, that powers the console uses a while loop. The pattern shown here is one way to handle repeated user input. This repeatedly asks the user for words until the string exit is given, at which point it will exit the loop. Users are notoriously untrustworthy, and they often make mistakes. A while loop can be used to safeguard user input and make sure that they are correctly entering data. The pattern is similar to before, where we repeatedly get user input until a condition is satisfied. In this example, we're repeatedly looping until we are given digits for the age variable. Another interesting use case for a while loop is to repeatedly pick random numbers. This is less of a specific pattern and more of a general use case, but the principle is the same each time. Basically, we use random, also known as stochastic, processes to repeatedly try solutions until one satisfies our constraint. In this example code, we want to pick two different numbers, so we call the randint function twice. If the second number is the same as the first number, we repeatedly re-roll the second number until the two numbers are different. There are often ways to achieve the same effect using complicated math, but a while loop can be a straightforward solution. Of course, in the worst case scenario, we might end up rolling badly each time and waste a fair amount of time waiting to find a good number. One more kind of loop you will occasionally see, but rarely write, is the main game loop, also sometimes used for servers and other long-running programs. Essentially, this is a loop that is never supposed to end. Some programs, such as games or websites, are not really supposed to end. The user is expected to just keep interacting with the game until the computer is intended to be shut down. Therefore, the loop uses the unconditional value true for its condition, meaning its body will repeatedly execute. Do not try running this program unless you know what you are doing. Almost always, other software, like Designer, will handle this kind of loop for you.